MCQ 31 is with regards to how metals is to be found naturally, and a way to do this question is to use the metal reactivity series. So using the shortcut of please send Charlie, monkey, and zebra in tall lead hunting cages securely gated with padlock, potassium being the most reactive member of them all and platinum being the least reactive member. So in the first column, to find the metal as it is in the wild, we're looking at the last four metals here, otherwise known as the cat metals: copper, silver, gold, and platinum, known as the unreactive metal. Because they are so unreactive, they will be found uncombined with any other things in nature. So we have B and C as a possible answer. For magnesium is too reactive and it will combine with other elements to form an ore to be obtained in nature. Now in the second set here, we're looking for using the reduction by carbon to get the metal of interest. Now this was also a shortcut mentioned in lesson. Zinc itself ends off with C, so it means that any metals coming downwards, metal oxide plus carbon will actually give us metal plus CO2. So the reduction of metal ore with carbon is only viable for any metal ores that contains metals from zinc and beneath. So we have iron and zinc, which are definitely from zinc and below, but no for B because sodium is too reactive. Now the question here did not mention, but there is another method to obtain metals from its ore itself, and that is the use of the reduction by hydrogen. So iron itself ends off with N. So this shortcut was also mentioned in class. Coming downwards, metal oxide plus hydrogen would have allowed us to reduce the metal oxide to metal plus water. This is only viable for metals that are iron and below. The remaining one, which is zinc and above, they are extremely reactive, and should we to isolate them from their ore, we have to employ electrolysis. Now again, one thing to note, it has to be electrolysis of their molten solution, because if it was an aqueous solution, hydrogen will actually be used, and since hydrogen is a least reactive cation, and cathode has a preference for the least reactive cation for selective discharge, the aqueous solution will see us getting hydrogen gas selectively discharged instead of the metal. So once again, if you want to discharge the reactive metals itself, for the case of electrolysis, it has to be with that of this molten electrolyte. So for the case of magnesium and sodium, which is way above that of hydrogen, you definitely have to use electrolysis of its molten electrolyte in order to obtain the metals of choice, so that hydrogen will not have interfered with the selective discharge process. So C is the correct answer for question 31.